Hello, it's been a little while since I've put some video out, 3 weeks mainly, because I wanted to finish my runner diorama. So I will post some little things around that because that was quite a challenge, but I've managed to do it. So I will be ready for the exhibitions and on the challenge that will be at the end of May in Saumur in France. So that's cool. Now, also the other thing is that in the meantime, so of course I didn't want to switch to FreeCAD 1.1 because I wanted to make sure that I could finish, everything. And if I had to redo some design and reprint anything, I would be able to do so. Now, of course, when I switched to 1.1 after that, then of course I had some little surprises, even with the Payan model. But okay, I've managed to deal with it. Most of it are linked to the discretization, I would say, tool that somehow needs to be reconnected to the original lines. But once you do that, everything is fine. It seems also that perhaps the loft algorithms have changed a little bit, so the shapes of my lofts were a little bit different. But in any case, everything has been bought back, and FreeCAD 1.1 is pretty good, of course, and I will show you, how I'm going from this stage, which is the last stage we were in, and carving out all the internals into this. Of course, most of the time you cannot use, the 3D. The 3D view of your parts because of the skins, because as you can see with the Karmans and everything like that, on with curves, with shapes like that, for example, this would never fly. So I will show you how I'm doing that right now. So to construct the interior version of the fuselage on the wing, in order to carve them a little bit, I will show you how I'm doing it. So you take all the cuts that you have. So here, for example, I've already copied the cut 1. Okay. Then you go into cut 1, and you will use this as a basis. So in fact, I will take that and I will translate that as a construction, and then I will replicate the spline here. So remember, 1, 2, 3, 4, 5, 6, 7, 8 points. Okay. This one is here. Okay. Okay. So that's it. I left that, so I will remove that for now. I will show you a little bit later what I'm doing there. Okay. So I have my B-spline, which is roughly the same. As usual, the same constraints about horizontal and vertical and everything. So this is horizontal. Okay. Now I will use distance here, and so here I will say that's a vertical distance, and this is where I will begin to use the resin thickness global variable here. So as you can see, I have my resin thickness here. Okay. And here I have also the same my resin thickness vertical distance. Okay. Now I will have a point here which is in the middle, and of course this point will be associated with that horizontal. Sorry, didn't get it. So up, up, horizontal. What did I do wrong? I said this point and this point horizontal. Okay, and that this distance is the same. Okay, so in order to control the fact that everything here should be, sorry again, I should have removed that. Okay, in order to make sure that, the width between the B-spline is always the same thing, so I'm using a little trick. So I will need two lines, so one associated with that, one like that. Those two lines will be, of course, construction lines. This and this will be in the middle. Okay. This and this will be equal. They do not have to, but that's easier. And in fact, they're going to be the resin thickness. Okay. Okay, and now I can take this point and this point to be equal, but also this other point, where is he? Where is he? It's over there. So this point and this point to be equivalent. And now I will ask this and this to be on the same line. So as you can see, this is fully constrained, and that allows me to make sure that the distance here is exactly the resin width. So that's the little trick that I'm using, and I will use that for all the points here, so between this point and this point. And I will do that and I will come back to you. So I finished this. It was using the little trick of T. I will put that on rear view so that I see only the one that I'm interested in. Okay. So, in fact, it was not very difficult, okay, with the little tricks of the T's, and then of course you had to do exactly the same constraints, okay, like verticality constraints between this control point, this true point of the curve, and then this control point here below, and then the as many T's as there are points in the curves, and that's it. So it's pretty straightforward. Of course, I do not use the 3D shaping and everything like that, because usually with pretty convex shapes, and I can tell you that especially near the tail it's going to be complex shapes that never works the way that I would like it to work. I've closed, as I said, or not, I've closed this profile, so that means that in fact this profile allows me to build a solid when I build that into a loft that I will use in order to carve out the interior of the fuselage. Now, remember that if you look at this cut interior, everything is associated with constraints that are associated with a column of the cut sheet. So that's very easy. You can do that by hand. So that means copy, paste, and then changing all the C's by D's, for example. Now, as I told you, I've already built my little macro here. So if this is selected, I click on my little macro and I say I want the column D, and all of a sudden everything is in D. And then I can do that again, colon, and then colon E, and everything is in E, and everything like that. So as you can see, it's pretty easy to have that. Now, of course, the little problem is that here I had to correct the original profiles. So I will show you how I've done that for those two special, I would say, cuts, because of course the classical technique does not work there. So I have all my cuts for the front fuselage. In a way, I do not need to make the separations between the inflated and deflated, I would say, versions of the real nose on the midsection here. I just need, one straight line or a straight loft in order to carve out the interior. And of course, if you use, I would say, this into a loft of degree 2, you get that. So that was the first version. Now, of course, we need to see what we have done for the other side, so the rear side of the fuselage, which is a little bit trickier, as I said. So to come back to the very special one, so the DD corrected here, for example. So what did I do? In fact, to control it in a way, so what I had to do is to make sure that the top point here was compatible with the resin width that I'm looking for. And so this is why I build a T at the beginning associated, connected to this vertical axis in order to make sure that here I have exactly, I would say, the resin width. And that means also that it's, I think, the one for which I had here only a tolerance point. So that means that I had an horizontal first control point that was very close to the axis. Okay, and then after that, I did my best in order to be able to go through the T's. Of course, the bottom part is okay, but the top part is a little bit trickier. As you can see, it's not exactly correct in terms of having, the same width exactly all the time, but that's good enough. The nice thing is that allows me to have something which is compatible with a different resin width, which means, and I will come back on that a little bit later, that I will be able to use exactly the same drawings in order to scale it up, I would say, for other scales, like, for example, 32 scales and everything like that. So I will leave that sketch here, okay? And I've shown you what I've done for that. Then there is also the last one here, so the E corrected, which basically is even more drastic. Here I'm going directly down, I would say. So the same trick here about keeping, the resin width, but then even the first control point here is not horizontal, in order to make sure that I have something. I would say compatible. And here again, it's pretty difficult to get exactly the good thing, but anyway, I've done my best in order to make sure that this would be correct even in other resin width. Okay. Then what did I do? Then for the very, very last part, okay, in fact, it's a little bit difficult, as you can see here. It's a little bit difficult to make sure that I have something which is again compatible with the resin width. Okay, so I had to do something special. Again, in order to have something that I can use independent of the resin width, but I mean going with the resin width, I had to make sure that I have some cones that were completely inside the fuselage, both on the, I would say, shell type of things. So what did I do? I've used the last two profiles, so especially I would say the maximum X, okay, so which is in that shell, in that sheet, sorry. And in fact, between the two profiles, I've drawn a line, and I've drawn a parallel line with the resin width difference of that until basically it hit 0.3 millimeters. So that gave me here the Y of the last, I would say, profile that I can use in order to carve out things, making sure that I have resin width matter, on the X side of it. Okay, so that was the, I would say, horizontal view of that, and I had to do roughly the same thing for the side view, which is the YZ. Okay, and so the YZ is exactly the same thing. So I've used here, I would say, the bottom expression, the bottom Z that there is in my sheet, minus the resin thickness. Okay, either for these cuts on the last cut, and that allowed me to know exactly when I was reporting, I would say, the Y of the last cut that I can use in order to carve out. This allowed me to basically know here what was the bottom of this thing. And then what I was able to do, is to draw those kind of things. So I didn't do something very fancy in terms of shape. Okay, I have just done something, which is a circle. Okay, um, you properly, I would say, set up at the bottom and with the proper radius. And then I've used something like 40 degrees. I could have gone a little bit less than that eventually, but that was okay with me. I didn't want to change a lot of things in there. And the good news is that because I had both, the maximum X and the bottom Y's, I could use exactly the same thing for the last curve here. So the interior tail. And that's exactly what I've done, setting up the bottom and setting up the things. Using expressions that came from the tail YZ and XY, I would say guide ASK that I'm using here. Okay, so that allows me to finish, I would say, the carve outs. Now, the thing is that, do you think that will work if I try to merge those things and then to carve them out from the fuselage? That's, I would say, the little intention in a way. And so if I put everything now into this thing, and this thing, I have, I would say, the thing that I want to carve out from my original fuselage. Now, of course, if I want to do that, I will not be able to, it will not work. So that means that if you try to do this and this and this and to make a fusion out of that, that should work. So you think you're good, okay, with that fusion. But then after that, if you try to extract that from, let's say, the fuselage wings on fuselage, so that means that the full, I would say, the full union of everything, all the solids that I've created. Okay, so I have the Karmans, the wings, and everything like that. So if I take that and I try to cut my union here, my fusion cut, it's working. Okay, so you think it's working, so good. Let's try that. And then you are trying to do that with testing Where are they? Test the XZ intersection, and it's working. So that's pretty good. And now you can go on doing whatever you need to do in order to make sure that you have, I would say, everything that um, a little, I would say, extract in order to show you why I love the FreeCAD solver. So, for example, let's assume that you have a profile just like that, and you would like to know at what level, at what wise, there are, I would say, for example, two resin width that is into this profile. That's very easy. So you take that, you create uh, a sketch onto that plane face. You integrate those two lines, for example, and then you create a vertical line associated with both, which is both vertical on both, I would say, collinear with these two lines here. And then very easy, you say, well, it's very easy. I would like to know when there is 1 millimeter here. And you see that the solver has done it very automatically, which means that, for example, if you say, now I want to know this as a reference, which is my y here, okay, if you change, for example, this to 1.5 millimeter, of course, that works. Now, of course, the little problem is that if you change that to 2 millimeter, the solver is failing and everything, but that's 1.3, and yeah, everything is back. Uh, and that I'm using that a lot in order to control everything from the resin width, for example. So here, for example, if I say that I want this to be twice our global sheet resin width, resin thickness, sorry, okay. Well, I have exactly the thing that I'm interested in. So I'm using this trick a lot. Really, that's really very useful for me in order to make sure that I'm using the solver in order to control things when I want, for example, to be able to change the resin width at one point. That's something that I wanted to show you because I think that's a neat trick. Now, the carving of the wings are, well, it's a little bit special because the wings are very thin, of course, and I want to let, I would say, resin thickness matter around the thing. So, how do I do that? Especially, how do I know um, where I can stop here? Especially if, of course, the end of the wing is less than twice the resin thickness. So that means that I need to stop somewhere the hole that I will carve into the wing. So how to know that? So first thing that I'm doing is that I'm using the front view of the wing, as you can see here, and I'm trying to find where there is a 2.5 resin thickness, in this width here. Okay, so here that's that case, and here there is the front resin weakness. Max E. Okay, so I have a little bit spelling problem here, but that's okay, and that's a little bit the thing that I'm looking for here. So now if I do close, my guess is that perhaps I've broke something because of that change or not. Well, we'll see. everything was good, everything has been found back. So that's the first thing that I need to know is where to stop. Now, as soon as I know where to stop, I can build here in the placement, in the position, um, I can build here something that I will use, at this layer here. This is the front XZ shape, whatever. So that's exactly the thing that I've corrected the spelling for. The little thing also is that sometimes I must make sure that this is obtained, but it's not longer. It's not at a point where basically the linear size, the linear portion of the wing is on. So which is given by this x2 here, which is, remember, we had a profile that is x1, a profile that is x2 here, and I need to make sure that this twice resin thickness is not after, I would say, the cut here. So this is why I'm using a minimum here. Okay. So in our case, that's going to be good. So here, that's something that allows me to build a, a surface that I can use in order to cut the front wheel itself, the front wing itself, and that gives me this. So now I know that at the maximum point here, I have 2.5 resin thickness. And the little thing is that I would like to make sure that here on this side, I'm using something in order to see where I have twice resin thickness, both on the front side of the profile, on the back side of the profile. So that means that here, this gives me, in a way, two Ys, the front wing internal front Y, and the back wing, the front rear interior rear Y, that I can use in order to control, I would say, um, the the shapes or the directions that I want to use in order to do things. So once I have all that, I can build what I'm calling the internal tool wing, which is using this in the front wing here. So using these two values here, so this one is the one that you've just thing here, okay? Okay, and this here, and then I'm using the middle between the two, and I'm doing something which is, I would say, parallel to the leading edge on either the trailing edge or the aileron kind of things that I want to keep, because I need to make sure that the distance between this and this is bigger than the resin width again. Okay, so this finally gives me these three lines, and these three lines are very important because that allows me to create, I would say, the like the front wing, that allows me to create again. So here I will not ask that for that, but that allows me to create these kind of things here that I'm using in conjunction with the front wing, with the front wing front shell, which allows me to give me those cuts here. And those cuts are again the one that I'm using, okay, in order to build internals profiles that I can use in order to carve out that wing. So now that I have those things here, I can also place some sketches on each of those faces, okay? in order to have these kind of things here. Okay, and again, if you look here, again, the idea is to use resin width. I know that at the middle I have twice 0.5 resin width, or more or less something like that. So I should be okay here. Okay, the whole idea is to finish that, and then I'm using again the little T's here in order to make sure that I'm following that shape here, and that will allow me to, I would say, basically cut out things in the fuselage. So if I'm doing that, that means that after that I can build my front wing interior here, okay, which is the thing that I will use in order to carve out things out of my fuselage. So if I'm looking at here my fuselage, okay, and then I have my front wing interior here, okay, I cut that and that gives me this. So okay, so here I will stop showing that, and that gives me this, which is exactly, I would say, the maximum that I can extract, from the wing, okay, leaving enough space to cut out the aileron and leaving enough space in the front. That's a little bit complex. I agree with you, but on the other hand, that's the only way that I find in order to make sure that everything will work, whatever, even if I change the resin width after that, okay, and I want everything to be parametric at that level. And that's, of course, something that I've used here. Um, then I've used exactly the same thing for the back wing. Okay, so the back wing interior is here. I had to adjust a little bit in order to make sure that I do not mess too much with this portion where I would say the two sections, of the front fuselage and the rear fuselage carves are there. So that's something that I had to do. And in fact, to tell you the truth, that's also the first time that I've used, I would say, this new tolerance tool. New tolerance tool that has been provided with FreeCAD 1.1. So I was pretty pleased to see that I didn't had to change, internal dimensions and everything like that. I just had to use this this tolerance tool that you can get from, you go from there, you go to part, compound, set tolerance, and that creates a new tolerance object, okay, which is here, okay, and then of course you have to play with the min and max tolerance, which is exactly what I've done. So sometimes you have to play a little bit in order to make sure that you can use this in order to cut. And to tell you the truth, I was very surprised to see that in fact this was working. And so that means that at the end I have this cut, which is a pretty clean cut with no artifacts, nothing. That of course you can slice and dice, and that's something which was, I would say, pretty interesting for me. A good move for FreeCAD 1.1, as you can see here. Now I can refine that a little bit further because uh, I want to make sure that I have holes here in order to let the resin flow. That one stuff, one aspect, and the second aspect is also the fact that I would like to make sure that I have two, I would say, guides in order to stick, little things to allow me to, I would say, plug the wingtip. And so at the end of the day, I have something which looks like that, which is everything put together, okay, with all the carving and everything like that, which is all working together with, I can also trace some slices and everything like that, keeping the resin width all together, and that is working. So yeah. This is a little bit complex, I agree with you, but on the other hand, that's also something which is compatible with changes into resin width. So I can make you a demonstration about what I mean by that. If I go to the global sheet, and I will in a coming session, I will explain to you a little bit more my global sheet here. But as you can see, the resin thickness is something which is 0.7 millimeters. Now, if I want to change scales, okay, there are things that need to be independent from the scales and things, of course, that will follow the scale. In fact, if you build something at the 48th scale, you can, I would say, multiply everything by 1.5 in order to have a 32 scale model. But the problem is that if you do that, of course, the walls of your model will be also increased. Now, if I want my walls to still be 0.7 millimeter at 32 scale, then that means that um, I need to reduce a little bit that wall thickness, that resin thickness, so that when I scale everything out at 150, well, my wall will be still 0.7. And that's a little bit something that I've baked in into my global sheet. So that's a little bit too complex for beginners and everything like that. But on the other hand, if I say that now I want to go to 32 scales, as you can see, my resin width is diminished. But when I will apply the 1.5 scaling factor that I need to do for in order to get from 48 dimensions to 32 dimensions, well, everything is back. And that means that if I'm looking at my view here, you can see that here at 32 scale, my resin width is something like that here, and it's something like that here. So that means that the walls here are much smaller, okay? But everything is working. Now, of course, that required a little bit of tuning, okay? So everything is working in such a way that when I multiply that by 1.5, I have a 32 scale, I would say, shell in a way that is completely okay. And when I multiply that, the wall thickness here will be 0.7 millimeter. So that required a little bit of, let's say, work in order to make sure that everything was working. But as you can see, things have okay. Of course, when you do that, you change that scale factor. There is a lot of things that they are changing into the models, like especially all the tune-ups that you've seen changing with the resin width and everything like that. And so, of course, that requires a little bit, I would say, of recomputes and everything. But as you can see, everything is back to the 48 scale and everything is okay. So I will save this work because I've changed the name of one of the constraints, so that's worth saving it. I think that's ending up here. Okay, now I have everything. And everything is okay into one piece. Now I want to separate the pieces together, together with I would say putting some strengtheners in order to make sure that throughout the curing process and everything, I would say my shapes are staying the same. And then, of course, I will go after that to detailing with straight lines and rivets and everything like that. Thank you for being here and see you next.